So hello dear students, in the previous video we have seen the circular motion of charged particle and the helical motion of charged particle in a uniform magnetic field. Okay, now in circular motion we have seen that, like, suppose this is the magnetic field, okay, transverse magnetic field directed inwards. V is the strength of the magnetic field. So this charged particle, it moves in a circular path. Okay, this is the center and radius is r. Okay, so if the motion starts from this point, suppose with speed v, so here also the speed will be v. Everywhere the speed is going to remain same, but the direction of velocity is going to change. But suppose the magnetic field, it is only up to this region. Suppose magnetic field is only up to this region. So then what will happen? See, here the velocity is v. Here again it will remain v, but the direction will change. So speed is v. So if the charged particle, suppose it is entering in this magnetic field, the magnetic field is confined only in this region. This is the thickness of the magnetic field. In this region you have magnetic field directed inwards. Okay, here there is no magnetic field. So this charged particle, it is going in this direction. Under the influence of this magnetic field, it will take this path and finally emerge out from the magnetic field region with this velocity. Okay, so this is the original direction of velocity and this is the final direction of velocity. So this theta, original direction and the final direction, this theta represents the deviation in the path of the charged particle. So here in this video I am going to discuss this deviation. How much is the deviation? Okay, so for that let me redraw this diagram. Now suppose this is the region of the magnetic field. In this region you have the magnetic field. Okay, so it is directed inwards, perpendicular to the plane of the board, directed inwards, and this charged particle, it enters this magnetic field region. Q is the charge, M is the mass, V is the velocity. So under the influence of the magnetic Lorentz force, this charged particle moves along a curved path and emerges out with same speed v, but the direction is changed. This is the original direction and this is the final direction. Okay, now for this curved path, from this point to this point, for this curved path, suppose this O is the center. So if I connect this 2 point, so this is the radius, this is r. Okay, now suppose this is point A, this is point B, this angle is theta. Theta is the deviation. Now as you can see in this figure, if there is no suppose there is no magnetic field, so in that case the charged particle would have gone in a straight path. Now if it is going in the straight path, then the direction of this velocity, suppose this is velocity v2 and this is v1. Okay, this is v1. So v1 is, magnitude of v1 is equal to v2 is equal to v. Speed is v, but v1, I am writing v1 and v2 because of velocity having different directions. Okay. So if there is no magnetic field, the charged particle will move in a straight path. So in that case, V1 and V2, and they will be in the same direction, they will be parallel. So in that case, this theta will be 0. Okay. Now, because of this magnetic field, if theta is 0, B point will be somewhere here. I can if a vector is moved parallel to itself, it does not lose its property. So we have V1 in this direction and V2 in this direction, and angle between them is this angle theta. Okay. Now if there is no magnetic field, V2 will also be in this direction because charged particle will move in this direction. So V1 and V2, they will be in the same direction. So in that case, I can move this V2 over here. So I can redraw it over here. So this is V2. So suppose now V2 and V1, they are in the same direction, theta is 0 degree. Okay. Now theta is 0 degree, I can bring V2 over here. So that means B and A, they are at the same location. So this angle will also become 0. Okay. Now in this case, in this particular case, this is V1 and this is V2, this is theta. Theta is the angle between V1 and V2. So because of, if V1 and V2, they are in the same direction, B point is at A, and V1 and V2, they are in different direction, then B is here, A is here, or V2 and V1, they are in this, V1 is directed in this direction, V2 is in this direction, theta is the angle. So I can say that this angle, if this angle is theta, this angle will also be equal to theta. So that means if this angle is 0, this angle is also 0, B comes to here. If this angle is not equal to 0, B is here, so this angle is theta. So that means if I have to find the deviation, deviation is theta. Deviation means change in the direction of the motion. Means V1, it was going, charged particle was going in this direction, but because of the magnetic field, it is going in this direction. So this is the original direction and this is the final direction. So it is getting deviated by angle theta. So finding this angle theta is equivalent to finding this angle theta. Now, if the magnetic field is in a region of thickness x, okay. Now normally in this, deviation is not going to be much. Okay, in the diagram I have exaggerated, but this deviation theta is going to be a very small angle. So in that case, this distance x and this curve path x, means the curve path from A to B, can also be approximated to be equal to x, because if this is very close enough, this distance and this straight distance and this curved distance will be almost same. Okay, because this deviation is not going to be much, theta is going to be small. So that means this arc length is x. Okay, now if you see this triangle, I can write theta, angle equal to arc length divided by radius, angle equal to arc length by radius. But this arc length AB, it is equal to x, so theta is equal to x by r. Okay, now as you can see this, for this diagram, as I told you, I have exaggerated, I have enlarged it, I have zoomed it. So that means this theta is going to be small angle. Small angle. Now if theta is small angle, I can replace this sin theta as sin theta. For small angle, sin theta is equal to theta, or I can write theta is equal to sin theta. So I can replace this as sin theta is equal to x by r. Sin theta is equal to x by r, or theta is equal to sin inverse x by r. So this will be the value of the deviation. This is how we can calculate the deviation by the suffered by charged particle in uniform magnetic field.